Hey guys, so here's the second part to your guys' spring final of 21-22. Okay, so here are graphs, and when we graph rational functions, you guys, we gotta find out a lot of piece of information, right? So first, when we see this, we first look for our y-intercepts and our horizontal asymptote. And when we find our y-intercept, you guys, this is where we have to set x equal to 0 and then solve. So if we set x equal to 0, all of these become 0 except these two, right? 6 divided by -6 is -1. So the y-intercept is 0, -1. Horizontal asymptote, remember we gotta look at all of the, I'll bring it back. We gotta look at this information right here and deduce and pretty much deduce by looking at the degrees. Well, both the degrees, you guys, are the same, and the coefficients for these two are 1 over 1. So your horizontal asymptote is 1 divided by 1, which is simply just y equals 1, which means you don't have a slant asymptote. And if we wanted to find more information, we have to factor these, right? This is what we called half-time. And if we factored both of those, we have x plus 3 times x plus 2, and x minus 3 times x plus 2. And if you look at this, the x plus 2's cancel, and our new reduced equation is called x plus 3 over x minus 3. Now, because something canceled, that's where we would have a hole, right? We set what we cancel to equal to 0, and that's when we'll find our hole. X equals -2. And we plug in this back into the original to find our y value of the hole. -2 plus 3, -2 minus 3, that's going to be -1/5. So our hole's -2, -1/5. Our vertical asymptote, set the denominator of your reduced equation equal to 0, which is just x is equals to 3. And our x-intercept is, you set the numerator equals to 0. And that's x plus 3, which is x equals -3, -3, 0. So we find all this pieces of information, you guys, and then we deduce what we can. But remember, you don't need to find all of this. If we just start in order, we can start picking away some stuff. So this one can't be it, because the y-intercept isn't at 0, -1. I'm strictly just looking at for y-intercept. That's 0, -1. This is 0, -1. This one is not 0, -1. So just by knowing the y-intercept, we took those away. Horizontal asymptote, well, A and B both have a horizontal asymptote at y equals 1, so that doesn't help. No slant. Now let's look at the rest. Well, there's a vertical asymptote at x equals 3, which is this one. This one doesn't have a vertical asymptote at x equals 3. Plus, this one's hole is at -2, -1/5, and it does have an x-intercept at -3, 0, which is right there. So this one definitely checks out, and it matches all of these characteristics right here. Okay, so for 16, remember, you guys, the original parent function looks like this for rational functions. Now, because it says plus 3 and -2, remember, this means you go left 3, and this means you go down 2. So from the center, it went transformation of left 3 and down 2, and then everything gets flipped. So left 3, so from the original graph, it went left 3 and down 2, and then everything got flipped. So it's not in these quadrants anymore, but it's in these ones now, because it got flipped. So if we moved all of this left 3 and down 2, your graph should look like 1, 2, 3, 1, down 2, left 3, down 2, and it should have been flipped. So it should be looking like something like this. So that is what your graph should look like. And remember, the vertical asymptote, it went left 3 and it went down 2. So one of our graphs definitely look left 3 and down 2, which appears to be either B or it is D. B or D. And I'm pretty sure I'm going with B, because this one looks like it got stretched while this one looks the same. I guess we should make sure, huh? 16B. Ooh, 16 is D. Oh, that means this one got more stretched and this one's the same. So again, move it left 3 and down 2, and again, you guys can always plug in a coordinate to see if it matches up too, or doing a test point. So don't worry, transformation, it will definitely help. So there's D. Now let's get to radicals, right? So for this, you guys have to get the same radical or same radicand. So, but first you gotta simplify this stuff. Well, we can simplify this for sure. 3, 9, 3, 3. Pairs left over, so the pairs go on the outside. So this 3 times that pair is 9 square root of 3, because that's the leftover. You can't simplify this and you can't simplify that. So plus 2 rad 6 minus 2 rad 3. These have the same radicand, so we can combine those. So 2 rad 6 plus 7 rad 3, which is D. 18. Now, because it has a index of 3, we're trying to find groups of 3 when we break it down, right? So this can't simplify, but these certainly can. So I'm just gonna rewrite all this stuff, you guys, and then break down these with trees. 16 times 2, 4 times 4, 2 times 2, 2 times 2, 9 times 9, 3 times 3, 3 times 3. Here's a pairs of 3s. Well, I'll do this. Pairs of 3s, left over 2, left over 2. Pairs of 3s, left over of a 3. Negative 3, cube root of 4. This group of 2's come on the outside, so 2 times 2 is 4, cube root of the leftovers, 2 times 2, which is 4 on the inside. And then here, these 3's come on the outside, and the leftover 3 on the inside. Remember to still keep the index. So both of these have the same radicand. So we got cube root of 4 minus 3 cube root of 3. And that's going to be B. That one is B. 19. Okay, when you guys multiply, it's just the outsides times each other times the inside. So 5 times 3, and then rad 8 times rad 2. 15 square root of 16. Now square root of 16, you guys, that's just 4, right? And 15 times 4, you guys, is 60, which is A. That one is A. 20. So now what we could do here is, wait, can we do that? No, we cannot. So we gotta multiply these together. So outsides times the insides. Positive 10 cube root of 45 times 3, you guys. 5, 135. And now let's break this down. Well, we know 5 can go into there. 2. 5 goes into that 7 times. 27, 3 times 9, 3 times 3. We found a pairs of 3's and a leftover of a 5. So bring the pairs of 3's to the outside, so 3 times this 10 is 30 cube root of 5, which is D. 21, when you guys do division, you gotta multiply top and bottom by the square root in the denominator. So we gotta multiply top and bottom by rad 6. So 2 radical 18 all over rad 6. Remember, you guys, anything times itself with square roots is just that number, with no more square root. So we get, and then let's simplify this rad 18. So that rad 18, you guys, becomes 9 times 2, 3 times 3, pairs of 3's, left over with 2. So the 3 comes and multiplies to the outside, so that's going to be 6 square root left over 2. And then you can simplify top and bottom by dividing top and bottom by 6. Rad 2 all over 5, which is C. 22. So remember, if there's two terms, you guys, you gotta multiply by the conjugate. So it's the opposite of the middle term. So now it's positive. And then this is where you guys gotta do a double distribution. And then the bottom, these two, and these two. Okay, so up top we have, oh my gosh, something just went in my throat. Hold on. Ooh. Okay, so double distribute up top. 2 times 3 is 6. 2 times rad 5, 2 rad 5. Rad 5 times 3, 3 rad 5. Rad 5 times itself, 25. Oh no, just 5. And then on the bottom, 3 times 3 is 9. A negative times a positive is a negative. Rad 5 times itself is just 5. Combine like terms up top, so it's 11 plus 5 rad 5 all over 4, which is A. That one's going to be A. Alright, now solving for radical equations. So, first, you guys got to isolate the radical. So I'm going to subtract 5 to both sides. And we get radical 10 minus 2m equals m minus 5. Now we need to get rid of the square root, you guys, so we got to raise both sides to the second power. 10 minus 2m, remember, m minus 5 squared, you guys, is m minus 5 times itself. Double distribute, 10 minus 2m equals m squared minus 5m plus 25. Simplify that just a tad bit, and we get m squared minus 10m plus 25. Set the whole equation equal to 0, so I'm going to subtract 10 to both sides and add 2m to both sides, because then these will cancel. M squared minus 8m plus 15, and then you guys factor that to get m minus 5 times m minus 3. So m's got to equal to 5 and m's got to equal to 3. But remember, you have to check your answers, and you check your answers by plugging it back into the original. And when you guys check, if you guys plug in 5 into here, right, 10 minus 10 is 0, square root of 0 is 0. And since m is 5, 5 would equal to 5. So this one works. But if you guys do this one, if you plug in 3 into here, 2 times 3 is 6. 10 minus 6, you guys, is 4. Square root of 4 is 2. 5 plus 2, you guys, is 7. But we said m was equals to 3. 7 would not equals to 3. So that means 3 would be an extraneous. So that doesn't count. So our only answer is 5. Your only answer would be 5. 24. Again, you guys raise both sides to the second power. 5x minus 1 equals x plus 1 times itself. Double distribute. 5x minus 1 equals x squared plus x plus 1. 5x minus 1 equals x squared plus 2x plus 1. Set the whole equation equal to 0, so I'm going to move everything to the right hand side. So we get that. Factor this to get x minus 2 and x minus 1 using x method, and x equals 2 and x equals 1. But again, you guys have to check, right? If we plug in 2 into here, 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 then is 3. So on this side we got 3. And then 2 plus 1, you guys, is 3. 3 equals 3. This works. If you guys plug in the 1, 5 times 1 is 1. 5 minus 1 is 4. Square root of 4 is 2. And then 1 plus 1 is 2. 2 equals 2. So both of them work. So your answer would be A. 25. Okay, so this, you guys, remember, if you guys have this denominator that is the root of this whole entire thing, right? And then raise it to the second power. So 3, if we break this into a tree, you guys, that's 6 times 36, and this is 36 times 6. Well, okay, if we break that 216 down, you guys, 2 times 108, 2 times 54, 6 times 9, 2 times 3, 3 times 3. We're looking for groups of 3, right? There is a group of 3 of 2s, and there's a group of 3 of 3s. So no leftovers, right? So it's just going to be 2 times 3 on the outside. And how many times does this 3 go into that 3? Once. So there's just going to be 1x. And again, all this raised to the second. So 6x, all raised to the second. 6 squared is 36. X squared is just x squared. So that answer is going to be D. That answer is going to be D. 26. So this is the cube root of 27, v to the 9th, all raised to the 5th power. Let's break this down. 3 times 9, 3 times 3. Pairs of 3s, no leftovers, so we know we're going to have 1 3. 9, 3 goes into 9 3 times, so that's going to be v to the 3rd, all raised to the 5th, and then you raise both of them to the 5th power. So v to the 3rd times 5, that's v to the 15th. 3 to the 5th power, you guys, right? 3 times 3 times 3 times 3 times 3, 243, which is C. Which is C. And then the last two for this video. Okay, again, these are transformations. With cube roots, you guys, those look like this. Those look like this. That's what cube roots look like. Write 1. Write 1. Down 2. Right? Write 1, down 2. So go from the center. Which one looked like I went right 1, down 2? Not that one. Right 1, no. Right 1, no. Right 1, down 2. It's D. 24. Now for square roots, you guys, they look like this, right? Square roots, they look like this. So right 3, down 3. So what one went right 3 and down 3? Not that one, not that one. This one. This one went right 3, down 3. And it's positive, so it should be going up. So again, just keep on moving along, you guys, and the last video will contain the last 14 problems, okay?